Good evening, everyone, and I would like to welcome you all here this evening to this MTU Open event for engineering. Those of you who are here in the hall, delighted to see you, and for those of you who are linking in remotely, delighted as well, and I hope that you find the evening very informative and interesting. My name is Joe Harrington, and I am one of two people hosting tonight's event. I'll host it with my colleague, Dr. Matt Cottrell. We're the two heads of schools of engineering here on the Cork campus of MTU. In terms of the structure of the evening, we'll start with a series of short presentations from each of the departments in engineering, talking about their courses. We will then have a question and answer session. We will have a number of our current students and recent graduates, asking them about their experiences both as a student or in terms of working, and how their course here in MTU prepared them for that transition into a work environment. And when we're finished with the formal part of the evening, there are a series of information stands around the hall here, and you can go to an information stand and there will be staff at the information stands, and you can ask whatever questions you would like to ask. We're kicking off here around 7 o'clock, and we'll certainly be finished before 9 o'clock. Just a number of housekeeping things as usual. So the first thing is the emergency exits. There's two up here and there are two down there. Okay. The second thing is, as we all know only too well, that we're in a time of COVID. We'd ask that you keep your mask on you, but obviously when you're drinking or when you're eating, it's fine to take off your mask. But otherwise, if you wouldn't mind leaving your mask on you. And the old one, the usual one, if you could put your phone on silent, that would be a good idea. And that reminds me that I better put my own phone on silent. So, we might start with two very quick questions that I'm sure you may have asked yourself. First of all, what is engineering? Why are we here at all? Engineers imagine and design and make much of what makes your life what it is today. The mobile phone in your pocket, the computer that you use, the internet through which so many different things work, the road that you drove to get here tonight, the buildings that you occupy and inhabit, the bridges that you traverse, the cars and the planes and the boats that bring you from A to B, the medical device which mightn't be inside in you, but it might be inside in a grandparent or a parent maybe, the clean water that you drink. So engineers are absolutely essential to our quality of life and the living that we do. And we would say that engineers are an absolutely essential part of building and maintaining a modern society. And there are many different flavors of engineering, and you'll hear about some of those flavors tonight. And the second question might be, why would you think of coming to MTU Cork to study engineering? We are the largest provider of engineering outside Dublin, and the Cork campus was the largest provider before we became part of the bigger MTU. We offer all the major engineering disciplines. We have a very established progression route, so you can come in on an ordinary degree program and find your way as far as a PhD if you wish. You'll hear more about that in the different presentations tonight. Our programs are very applied, very practical, and made to suit the graduate who goes out to work in industry. Across all the disciplines that you'll hear tonight, our graduates are in extreme demand. There is a really, really strong demand for engineering graduates right across the board. We've introduced work placement, which is a central feature of our programs, and we also have generally accreditation from external professional bodies for our programs. It means that your qualification is recognized here in Ireland and internationally if you wish to travel. So there are just some of the reasons why you might think of engineering here in MTU Cork. So I'm head of School of Building and Civil Engineering, and the first part of the night we'll have three brief presentations from the departments in the school. We educate and train students to become professionals primarily in the construction sector here in Ireland and internationally. A sector that's again booming in Ireland after it came out of the dormant period during COVID. And many of our students work abroad for a period of time. And within the school, there are departments of architecture, civil and structural engineering, and construction. And I'll start and I'll talk about architecture for a few minutes, and then I'll pass over to my colleagues who'll talk about the other programs. So we have a Department of Architecture here in MTU Cork, and we deliver across 3 different disciplines: architecture, which we deliver jointly with our partners in UCC, architecture technology, and interior architecture that we deliver here on the Bishopstown Campus of MTU. So the students in this department have very, very good facilities. So if you look up here, the facility on the left-hand side is the architecture factory. It's a building here on the Bishopstown Campus in that direction. It was a factory floor. It's a large open space where our students can work in an inclusive and imaginative environment. It's an absolutely fantastic facility. And on the right-hand side is our new purpose-built building on Douglas Street near Cork City Centre, where the architecture programs are housed. This building was built specially for architecture, so another fantastic facility. So we've 3 disciplines. The first of them is architecture. So architects plan and they design buildings and structures, whether they be new buildings or maybe refurbishing existing buildings. And they design in the context of the environment around them. And obviously, in today's world, they design in a sustainable manner. And clearly, issues related to climate change are central to that design now. And you can see there on the left-hand side a couple of structures there in London, designed primarily by architects. And here in Cork, we have a joint set of programs in architecture, joint between MTU and UCC. So we have a 4-year, you can see on the right-hand side of the slide there that we have the entry to the program is into a 4-year honours degree, BSc Honours in Architecture. Most students then take a year out and work, and they come back and they finish the final year, which is a Master of Architecture program. So it's a 5-year integrated program. The students are based in this purpose-built building in Douglas Street on the way into town. We bring about 45 students into first year. The points this year were well north of about 500. The demand for the program and the demand for architecture programs in general is quite high. The program is fully accredited through the Irish professional body, the RIAI, which means that our students can travel and work abroad. And incidentally, for those of you interested in architecture, there will be an open house inside in the building on this Thursday from 3 to 5. There'll be talks and there'll be tours. So if you're interested, be inside around 3 o'clock on Thursday and you'll get a tour of the building. So this is one of the few joint programs that we have between MTU and UCC, and it's the first of its kind in the country. We've been running it for about 15 years, very, very successfully. And it's a studio-based program. 50% of the time is spent in the drawing studio and the other 50% in supporting modules. The second discipline that we offer in architecture is architectural technology, often called a technical architect, and it is now a recognized discipline in its own right. So the technical designer deals with things like building regulations, materials, connections, and is a central part of the design team. And here on the Cork campus of MTU, we offer a 3-year ordinary degree and a 4-year honours degree in architectural technology. And on the right-hand side of the slide there, you can see the 4-year program and next to the 3-year program. So you can do the 3-year ordinary degree, and if your marks are good enough after 3 years, you can transfer it into the 4th year of the program and come out with an honours degree. Or after 3 years, you can go out and you can work. And there's a lot of work for people who leave after 3 years, and obviously again after 4 years. The points are presented there, and the points have risen a lot in the last 2 years. Again, there's a lot of demand for graduates of these programs. We bring about 45 students into first year into the architecture factory. It's a studio-based program again. They spend about half the time doing design and doing drawing, and these programs are fully accredited through RIAI. Again, it gives you a license or a passport to work and travel abroad. And we introduced 2 years ago work placement into third year, which is proving very successful. We have a group going out in 2 weeks' time, and industry are delighted to get the students, and obviously the students are delighted to get the experience. And the third discipline within the Department of Architecture is interior architecture. And as the name suggests, it's all about designing the interior of buildings. either new buildings or what's happening more and more, and will happen in Ireland a lot more, the design and refurbishment of existing buildings. And interior architects may have particular specializations in materials or layouts or whatever. And again, this has become quite a distinct and clear profession in its own right. Again, we offer a 3-year and a 4-year program. Again, you can, after 3 years, go out and work, or if your marks are good enough, you can progress into 4th year. So again, the choice is there. Points are there again, and we have seen quite a significant increase in points on these programs in particular in the last 2 years. Again, a lot of demand for our students and a lot of interest in the programs. We, again, just like architecture technology, we bring in 45. So we bring in about 45 into each of the 3 programs in the department. And again, 2 years ago, we introduced work placement. The students go out into work placement in January for a period of time. And again, they're very, very happy with it. So that is a flight through the 3 programs in the Department of Architecture. At the end of the night, you can go to the stand if you wish to get more information. So 3 strong programs, and that's one of the departments in the school. Now, I'll hand you over to Des Walsh, Head of Department of Civil Structural and Environmental Engineering, who'll talk about the civil and structural engineering programs. Okay, thank you very much.
Good evening, everyone. Good evening to everyone in the hall, and good evening to everyone joining us online. We're delighted to have such a large crowd here with us this evening. As Joe has said, my name is Des Walsh. I'm Head of Department of Civil, Structural and Environmental Engineering here at MTU Cork. The first thing I'd like to do maybe is to talk a bit about what are civil engineering, environmental engineering and structural engineering. Civil engineers are that discipline which deals with the planning, the design, the construction, and the operation and maintenance of large infrastructure projects. So it's the larger end of the construction industry. We're talking about things like, buildings, roads, bridges, energy infrastructure, foundations, the provision of safe drinking water, the disposal of wastewater. And within civil engineering, you have various specializations such as environmental engineering or structural engineering. So civil engineering is the broad term associated with the large infrastructure projects. One of the advantages of for someone who opts for a career in civil engineering is that there are opportunities to work in an office-based environment or on a site-based environment. So we find as the students go through our programs, some people prefer to work outside, they prefer to be with a contractor, they prefer to be building things, organizing things. Some people prefer to be in design offices, planning, designing, calculating. So there are both those opportunities for students who come in to study and ultimately pursue a career in civil, structural and environmental engineering. We offer 3 programs in the discipline. We have a level 7 program in civil engineering, we have a level 7 program in environmental engineering. The first 2 years are common between those 2 programs, and in the 3rd year then, the environmental program, those students take specialism modules in environmental related areas. Our level 8 is in structural engineering, and it's a broad civil engineering program in the initial years, and then it specializes in structural engineering in the latter years. And the department is also responsible for the management of the and administration of the Engineering Common Entry Programme, which allows direct access to year 2 of either mechanical, biomedical, structural, sustainable energy engineering, or chemical and process engineering. So that's quite a popular program. And I don't really have time to go through the details of that. But you will find them in the brochures which are available as you came into the hall and on the tables. So the details in relation to the Common Engineering Entry Programme are in both brochures from the Building and Civil School and from the Mechanical and Process School. In terms of how we approach what we're doing in the department, we put a lot of emphasis on practice. In the early years of the program, we try to ensure that students get a number of site visits so that they can see, what it is ultimately that they have the potential to work at or work as. And very often when we go on these site visits, we're being hosted by graduates of our own department. So, the graduates of the last 20 years have reached senior positions within various companies, and they're willing to provide us with opportunities to show the graduates and workers of the future in the discipline what exactly is involved. So the previous slide there, that's a site visit that was undertaken in the last few weeks. It's the Crow's Nest down at Victoria Cross, the student accommodation there. And another visit that happened recently was out to the Macroom Bypass, which is a very, very large-scale project underway at the moment, 280 million euros worth of work. We also have a very strong civil and structural engineering student society within the department, and this society allows students within the various years to get to know one another. So first year students get the opportunity to mix with final year students, second year students, third year students, through a series of social events and through a series of academic events. So the society is a very important part of how we deliver our programs at this stage and how students get to know one another. The society has won the Best Academic Society for a number of years, for 2 or 3 years recently, so it's a very strong society. The highlight of the society activity during the year is usually a trip abroad. The photograph there on the left is from the trip in 2019 to Barcelona. Work placement, as Joe has already mentioned, is a very important part of how we do our business and how we get the students familiar with what the opportunities are for their career. We have work placement modules running for the last decade or so, and depending on which program the student is in, the student might be out for as short as 10 weeks or up to possibly 9 months. Some of the logos here are representative of the companies who have given us work placement opportunities in recent years. And I suppose the benefits of work placement are the student gets to see what he or she will be working at, whether they want to work on the construction side, whether they want to work on the design office side, whether they want to work on the operation and maintenance side. And ultimately, a lot of these companies will offer graduates a job opportunity when they're finished their qualification. Work placement, the diagram on the left indicates some of the things that the students associate with work placement, and confidence and experience are the two main ones. Students, when they come back after work placement, have a much better sense of what their career entails, and they become a lot more focused on the opportunities that are in the sector. Just a quick review of what the CAO entry points were in 2021. So the points are listed there on the diagram, and they're available also in the handbooks. People very often focus on the cut-off points, which are the minimum points to come into the course. I've also put up on the diagram here what the median points are. So if we take, for example, the engineering common entry, the cut-off was 475 points in 2021, but the median was 500 points. So half of the students half of the students of the entry cohort this year had in excess of 500 points. So it gives you a sense of the demands of the course. Progression opportunities, just briefly to touch on those. The level 7 students have the opportunity to progress to a level 8. Many of them go on to do the level 8 in structural engineering. It's a further 2 years of study. Those that are interested in the construction and site end of the industry have an option to do a BSc Honours in Construction Management, which is a one further year. Or there are other opportunities within the faculty in MTU. The level 8 structural engineering students, at the end of year 3, they can opt to complete their level 8 BEng Honours by completing their 4th year, or they can divert on to what we call an integrated master's and do 2 further years to get a level 9 master's degree. I suppose to wrap up, we're all very familiar recently, and we hear a lot about the climate change agenda. We hear a lot about Industry 4.0 and the digitization of the industry. We hear about the challenges in terms of housing and student accommodation and infrastructure generally. And for anyone who is interested in these areas and interested in contributing to the development of these areas in the coming years, you know, a career as a civil engineer or in one of the related disciplines is very well worth considering. Finally, just to remind you that there are a number of scholarship opportunities available for many of the engineering programs within the faculty. Within my own department, we have an ARP-sponsored scholarship to the structural engineering program, but as I say, there are plenty of scholarship opportunities for many of the programs across the faculty, and for more information on those, I suggest that you visit the MTU website. So I'll hand you back to my colleague Joe. Thank you very much.
Thank you, Des. I'd now like to hand over to Dr. Daniel Cahill, Head of Department of Construction, and Daniel will outline the programmes in his department.
Thank you, Joe. I won't elaborate too much. I'll give you some of a background and some context. And on my first slide here, it comes with a quote. I mean, it's said that we build our buildings, we shape our buildings, and then our buildings shape us. And I suppose the context is that we spend the majority of our lives, I mean, in buildings and using infrastructure that provides a vital space for everything that we want or need to do. And this built environment is also of vital importance for us in that it gives us a sense of place where we feel we belong. And yet we take this built environment and its surroundings for granted. We don't appreciate its existence as we move around or occupy it during our everyday lives. It just always seems to be there for us. However, the importance of our built environment and infrastructure at this moment in time cannot be overstated. My colleagues have indicated that already. Urbanisation, housing crisis, climate change, COP26, I mean, is indicative of that. They're very, very real problems that most nations are grappling with. And we're also seeing the start of what has been called the fourth industrial revolution. It's enabled by digital, robotic, and 3D technologies that are merging the physical, digital, and biological worlds, and are having major impacts on what we produce and do, how and where we do it, and indeed how we earn a living. The age of digital is upon us. It's part of everyday life. It's disrupting and reforming industries across the globe. It may seem at times that all that is solid melts into air, to quote Karl Marx. However, we are still rooted in our physical world, despite our online activities and the endeavours of Mark Zuckerberg with his metaverse at the moment. And now, because of the global pandemic, some of the trends that may have been apparent already, they've accelerated to an extent that it seems that we've been catapulted into the future by about 30 years at warp speed. For some, location and a more environmentally sustainable lifestyle is becoming an option. Whilst the hope is that everything will return to normal once the pandemic is over, a more preferable hope might be to return to better. In any case, the result of this will be substantial changes in the way our built environment and infrastructure is developed and experienced in the near future. The fourth industrial revolution technologies are also impacting the construction industry to a similar extent, as our building and infrastructure development shifts away from old and archaic processes. Preconceived ideas are being challenged, and the industry is building pathways towards solutions where digital and physical interact. Architects and engineers, as has been noted, they now create digital twin models of buildings, and this creates access to a wide range of data that can be used by construction managers and quantity surveyors to collaboratively convert the design intent into a physical reality in a more efficient and effective way. With a longer-term view to the future, well within the career span of current graduates and prospective students, it's actually predicted that much of construction work will be automated with dynamic new materials and possibly even managed remotely. It's worth noting that even despite this technology, there's still a human side to all this technological change. It's people that make the digital transformations work, not the technology itself. And given all of this technological change, a more appropriate view of construction professionals suggests that they should be considered to be sophisticated users of technology and data, not just stereotype wielders of bricks, concrete, and steel. So how can someone become part of this industry that has immense influence over the shape of the world that billions of us experience every day, that enables almost every role in society, whose output lasts for generations and touches more of the population than any other, that has the ability to overcome the challenges that are being faced throughout the world and make a positive difference? The best starting point is to come and study for a construction professional qualification here in Munster Technological University. Of course, there are all the other engineering degrees as well, but my preference would be for you to come and do either the quant surveying or the construction management. Our construction professional programs provide our students with the necessary creative, technical and business skills that form the basis for a very rewarding professional and managerial career in a vibrant and dynamic industry. There are 2 specialist degree options to choose from. The construction management degrees, that's the MT 856, MT 758, which is the common entry. They equip our students with the necessary skills for the overall planning, coordination and controlling of a building development from start to completion. And the quantity surveying degrees, MT 857, and again the common entry MT 758, prepare our students to manage the finances of a building development from initial calculations to final cost. So come and study with us to become creative, industrious, resilient, adaptable, sophisticated users of technology and data and build the future, whatever that might be. Thank you for listening.
Thank you very much, Daniel. So with Daniel's words ringing in your ears, we'll now have a short video, and Dr. Matt Cottrell and his colleagues will take over and will give presentations on mechanical, electrical and process engineering. Thank you very much.
My name is David Kinney, and I'm a fourth-year mechanical engineering student and scholarship recipient in MTU. I recently competed in the Tokyo Olympics and won silver in the European Championships. The sports department in MTU is a fantastic asset to all aspiring athletes and played a huge role in my road to Tokyo.
What I like most about societies is how you can meet a lot of great new people with shared interests. In MTU, there's a lot of great societies, whether you're interested in film, art, dance, music, there's kind of something for everyone. They're all student-led and they're all a lot of great fun.
The campus is unbelievable. The new sports centre is top-notch. The facilities are really great. The gym is unbelievable, and the people that work there are really nice as well.
I love societies as it is an excellent creative outlet. It always encourages us to think outside the box and come up with something new. It is a great learning experience.
I joined rugby club in MTU because it's something that my family have always been interested in, and it's something I never took up. It gives you a distraction, you can work on your fitness, and you can just relax after it. The social activity is brilliant, the amount of people you get to meet, people in different courses. It's good crack, like, you know, and you get a lot of fitness and you make friends for life, really.
Yeah, just societies overall have been nothing but great. The amount of friends that I've made, the new connections that I've made, some of them I would say are definitely lifelong friends. I don't know, it's a very joyous experience.
Oh, I would say 100% come here. The people are amazing and the staff, everyone is so friendly and helpful. It's the best.
Okay, thanks for that video, and I suppose it gives you an insight into, it's not just all being in the classroom or in the lab or the workshop. They are excellent sports facilities and other to support sports and other activities on campus, and we can just see the latest addition is the sports arena, which will be opening sometime next summer. So the very comprehensive range of facilities available to all students across the college, and everyone is encouraged to participate. So we moved to the School of Mechanical Electrical Process Engineering, and there's 3 main departments we're going to present programs from here tonight. My name is Matt Cottrell. I'm head of the school, and of colleagues Niall Morris and Martin Hill will be presenting as well. So just to say, I suppose, to mirror what a colleague said earlier about engineering, particularly in this area of engineering, we're talking about taking concepts through to reality. So in all engineering, somebody comes up with an idea, it can be, and it'll respond to a real need, because in the end of the day, as well as something work, it must make money as well, and that's where the accountants come in. But anyway, nothing against accountants, but obviously. But anyway, we'll move on. So in engineering, you come up with the concept. Firstly, you must design it. Then you got to test that idea. Does it work? Does it do what it says in the tin, as they say? You then got to make it, test it. It then goes out to the market for use, and then you have to consider, what do you do when you're finished with that product? How is it going to be recycled? And this is where you moved into the concept of recycling or the circular economy. And all these, with climate action and with other initiatives, these are becoming, it must all be considered as part of the cycle. So looking at programs within mechanical, biomedical, manufacturing engineering, we have level 7 and level 8 programs in mechanical and biomedical engineering. So what is mechanical engineering? I suppose this slide here focuses on mechanical. And mechanical would be, I suppose, any system that involves moving parts, from, it could be a heart valve, through to an aircraft engine, through to an automobile, through to a crane. So all those parts must function and work together, and they can either be highly automated or it can be a very manual operation. And the human factors, the controls, all of these must be considered as part of the design. So you've got to make, in lots of applications, things have to be lightweight, particularly if it's going to be mobile, and particularly those challenges are very apparent when it comes to, say, aircraft or even sports. You know, if you look at the evolution of bicycles, they were originally made of maybe timber, they then moved to steel, they then moved to aluminium, and now to carbon fibre. And all of that is to respond to the need to make items with lightweight and functionality. So it's also, you're combining different disciplines. So you have materials, you have controls, you have electronics. They're all part of the mix. And no one person can do all the, well, they can try to do it, James Dyson maybe, but normally even James Dyson will rely on teams of engineers to bring a product together and bring it to market. So, as I said, we have design, we have research and development, and you've got to make things to a consistent quality. So, customers have expectations, and they don't expect something to be break or wearing out within a reasonable lifespan. And so part of that might be some things you might maybe use or throw away after use. Others, you will maintain on a regular period, whether it's a motor car, motorbike, bicycle. They all require maintenance to keep them operating in top shape. So we feature all these disciplines: materials, machines, machine design. I suppose design is what brings it all together, really, and that's the core of all engineering is design, because there you're solving unknown needs and unknown problems. And what engineering does is it gives you the basic tools to tackle those. So I think here you can see, if I can read it there now, the makeup of where graduates have gone in recent years. And you can see that's the typical market as to where graduates go. And I suppose, particularly in mechanical, it's a very broad-based discipline. So you can end up, as I said, working from anywhere from the medical device industry through to offshore structures, through to power plants, so forth. So it's a very broad-based discipline with many application areas. Biomedical engineering is specifically geared at the development and deployment of devices to assist or to be implanted in the human body. So we've become increasingly familiar with, parts that are implanted in the body, whether it be artificial joints, corneal implants, cochlear implants for the ear, so forth. So these may be devices that are implanted, or else there could be tools or devices that are used in hospitals and surgeries and so forth going forward. So it's a huge part of the Irish economy now. The medtech sector, the annual exports now are of the order of 13 billion. So you can imagine the tax receipts that are coming into the economy from this sector alone. So biomedical engineering brings together a knowledge of human anatomy and the clinical needs with engineering knowledge, and that's where it's a confluence of those two disciplines. So that gives you some idea of the 14 of the largest global medtech firms worldwide are based in Ireland. It's a massive international industry, and Ireland now is truly a global player in this market. I mean, for instance, 70% of all the artificial knees in the world are manufactured in Ireland, along with huge numbers of stents and other devices. In fact, all the Botox in the world is made in Ireland, but it's all for export. Nobody in Ireland needs that, really, So it's all just goes for export. So, so anyway, that's a profile of the industry, and there's huge opportunities within it, both locally in Munster and internationally. I won't go into any detail on the entry requirements. Generally, on our level 8 degrees, we're looking at for higher level maths. On the level 7 programs, we're looking for ordinary level maths. And there's also routes from common entry into biomedical, mechanical engineering, sustainable energy engineering, as that's another possible entry route. So, again, as I said earlier, these are some of the areas that biomedical engineers in particularly go to work. It could be in device manufacturing, in research and development, clinical engineering, which is working with teams of doctors and other clinicians in a hospital or surgical environment. And then, a number of our biomedical engineers have actually gone to work on graduate programs with Apple. So, as again, the skill set, while it is biomedical, the skill sets are very broadly based, and graduates have a wide range of careers to choose from. So that's the broad structure of the streams. We have level 7 programs, level 8 programs. There's various pathways to move from level 7 to level 8, and now on to level 9 as well. We have integrated masters, which allow graduates from our level 8 programs to undertake one 40-year study, and they get a level 9 master's degree qualification, and that's available in both mechanical and biomedical engineering. As colleagues said earlier, there's a range of scholarships as well. Dupree Synthes, Johnson and J&J offer scholarships at entry for now it's a competitive process, so they get scholarships at entry, but they're also supported the full way through their program of study, both financially and in terms of work experience and career opportunities afterwards. So really the programs are broad-based, offer a wide range of activities while you're here in MTU, and also a very broad range of well-rewarded career opportunities thereafter. So on that basis, I'll finish with the Department of Mechanical, Biomedical, Manufacturing Engineering, and I'll pass over to Niall Morris, who's head of Department of Process Energy and Transport Engineering. Thank you.
Thanks, Matt, and thanks everybody for coming here tonight. It's great to see such a crowd, and everybody online as well. So the Department of Process Energy and Transport is made up of 3 distinct streams: automotive, chemical engineering, biopharmaceutical engineering, and Sustainable Energy Engineering. While there are 3 different streams, they have certain connectivities within the programmes. So to begin with, we'll just talk about the Level 7 programme in Automotive Technology and Management. That's a 3-year programme, and it also has a 1-year add-on degree for level 8. Sorry, to get your level 8. So the 3-year programme would lead on to the 4-year, where you do your work placement in year 4. But you can leave after year 3. You have a situation where we've huge employment from both of the automotive programmes. Generally, students are placed in full-time employment practically before they leave. They end up being asked to go in to do some work experience even from first year, so throughout the entire programme. So the programme itself, in all the programme streams within the department, we pride ourselves on the amount of lab-based activities. Usually up to 50% of the weekly structure is made from lab-based activities. So again, blended practical and theoretical-based modules. I've mentioned the high employment and success for graduates. So there's a wide variety of jobs. So from motor dealerships, so people tend to look at automotive originally as fixing cars, but that's not what we're about here for most part. While we do understand the knowledge of cars and transport, it's more on the after sales and looking after customer service thereafter. There's a lot of technology nowadays in cars. There's an awful lot of technology also in the after sales departments. Last year was the first year we had a full throughput then of our level 8 ab initio degree, where we take people into a straight level 8 degree programme. The reason for this was it was widely required by surveying companies out in industry due to the lack of skilled personnel. So it was introduced in 2020. This is year 2 of the programme. We hope to have graduates, the first graduates out of MTU in 2024. There's work placement in this programme integrated into year 3 of the programme. We haven't got there yet. So next year will be our first time with year 3. So again, the emphasis for this programme is more into the line of senior management within the roles of automotive energy, or automotive and transport, I should say. So you can just see, even the picture on the top left there suggests the amount of technology built into a car these days. Even the key of a car contains a substantial amount of information now when you swipe it inside in a dealer. It contains all the ownership details, it contains all the history of service and all that sort of stuff. So to back that up then, we have quite a substantial amount of dealer management softwares which we have access to here within the college. Moving on then, in the careers in motor industry, it just gives you a highlight there for after sales, technical roles within the department, parts and sourcing, financial and accounting, administration, vehicle sales themselves, which is not one of the major roles that we'd find ourselves in, but within a company structure then you'd end up possibly in HR and recruitment. So there's a wide variety of career paths ahead of you. The next part of the department, or stream in the department, is chemical and biopharmaceutical engineering. Again, you have the code there. Again, Des had put up the slide earlier on, but sustainable development is a part of any of our engineering programs these days. So you don't design just for a lifetime of the product, you design for its completion. So chemical engineering would hit quite a good few of those sustainable development goals, and the aim is to reduce emissions, which is part of our sustainable engineering program here as well. So on the left we just have a chemical reaction type of a symbol. It's just to give you an idea. So chemical engineers transform raw materials by physical, chemical and biological means into useful products. And on the right hand side we just have a bioprocess, a typical type of layout of a bioprocess from reactors, agitators and the like. So you take a raw material and you end up with a useful product at the other end of it. There's a diverse and dynamic variety of careers, just given some of them on this particular slide here, from petrochemical, tableting plants, spirit production, chemical productions for cleaning and so on. The petrol and that sort of a market, we're looking at now in chemical engineering, aiming to reduce, obviously, all petrol usages within any environment, let it be through road transport. So you're looking at bio-based feedstocks and so on and so forth. So aiming to look at the planet in a very sustainable way. Graduate employment, so very high percentage of graduate employment to date. We were going to leave in 100% graduate employment. There's practically 100% graduate employment from this chemical and biopharmaceutical engineering course. Highly paid graduate salaries, leaving onto a salary between 30 and 42,000 in 2020. Several of our final years have job offers already. Part of this is, again, some of my colleagues had mentioned work placement. There's a 6-month work placement with chemical engineers. The placement is looked after by MTU. We have a placement officer that will source companies, and we have companies in the books. So work placement is a huge part of it. Throughout the work placement, then, you're in a position to end up with your final year project, which is a huge part of any engineering degree. So a lot of engineers in chemical engineering and biopharmaceutical engineering will have their final year project coming back in or have started it while they're out in their work placement, which is a huge benefit. So the accredited degree, it's accredited by ICME, so it's accredited to master's standard in a 4-year program, which is very unusual, and it allows you then to work abroad quite easily. So graduates working in many sectors, but the majority then in the pharma and biopharmaceutical, which of course down around Munster area is a huge employer. The third stream within the department then is sustainable energy engineering, which obviously with the summit and everything going on at the moment is huge talk. So the future energy sources that are not sustainable are not a long-term solution. Okay, we're all very aware of that at the moment. Are you ready for the challenge? So again, some of the core activities within sustainable energy engineering. So we've lectures and we've laboratories, field trips, guest lectures, project exhibitions, which obviously COVID had a bit of an impact on that. Again, work experience is based in semester 2 of the sustainable engineering program. And again, we have a placement lecturer involved in getting and sourcing placements for them. And again, clubs, as one of my colleagues mentioned, or Matt mentioned, clubs and societies is a huge part as well. We have a mentoring type of a program running for this is the 2nd year of it, for first years and 2nd years within the different streams, automotive, sustainable and chemical, and across the university, just to encourage and help students out that might need a bit of a hand, in particular throughout the COVID seasons. So the course content, so you'll have the, like I won't go into it all in detail, sustainable energy systems, solar energy, wind energy, sustainability and transport. So it hits every sector, hydro and ocean energy. If you look at even some of the other programs within the university here, even when you go over to tourism and hospitality, again, you're building in a sustainability element to all of those programs at this stage. Again, so we're all well aware of the wind turbines, we're all well aware of the BER rating in houses these days, we're all well aware of emissions coming from cars, we're all well aware of that if we have a new house these days, we have to meet certain criteria, whether it be solar panels, air to water, or air to water heating and so on. So we must match targets. We all know the targets. We're listening to it in the news at the moment. So we're up and running with the last over 10 years in sustainable energy engineering with our honours degree. So we're ready to face those challenges. So again, jobs are endless possibilities, and that's just a few photographs of the different areas that are available to graduates coming out from the programme. Again, a huge list of jobs awaiting. So we just have a few slides, like some of my other colleagues, of the different companies where students are number 1 getting placed and number 2 getting employment after their graduation here in MTU. That's the process engineering and transport program. So I'll hand you over there to Martin Hill for electrical and electronic. Thank you all for coming. Great to see you.
Right, so I don't have a fancy opening slide. I should have had. So in our department, electrical and electronic engineering, we have 5 programs that I'm going to talk about. But before I do that, I'm just going to say one thing about MTU. It struck me, I came here from UCC, and I won't talk down UCC, but even from tonight, right? So you've come out, people have come online. I think in MTU, what you want to do is learn. So the primary thing here is ask questions. Start tonight. Go around, ask questions. For me, it's one of the best things about the engineering schools in MTU. Classes tend to be small. Some of the previous speakers talked about the societies, how the students help each other. But there's a very strong bond between the students and the lecturers here. They're all on first name terms. Our lecturers do the practical activities with the students, and that means they get to know them, right? So starting tonight, ask the questions, learn what you want to learn, try and make the most of this evening, and if you do choose to come to MTU, from day one, put your hand up. Don't be the person who sat down the back and got lost, right? So I think, so we have a level 7 and a level 8 program in electrical engineering. We have a level 7 and a level 8 in electronic engineering. And then we have a new program which will start in September 22 in smart product engineering. And just again on the progression thing, I would say probably 3/4 and maybe more of our level 7s complete their level 7 and then go into an add-on year to complete their level 8. So the progression path is open to you, and again, I think that's a real positive for MTU. So people ask me what is electronic, what's electrical engineering. So electronic engineering for me, they have so much in common. They both deal with electrons, circuits. The difference between them is that the scale of the project you work on. So if you're an electronic engineer, you're likely to be working with some of the pictures that are on, I'm going to say on the right as you look at it. So you're going to work on things like computers, so building computers, that's the inside of a laptop, mobile phones, Fitbits, and then in the future generation, you're going to work on, one of the previous speakers talked about Industry 4.0. Industry 4.0 is about everything being connected. They talked about smart buildings, everything being connected, collecting data on the bridge so that you don't go out every 6 months. You continuously monitor the bridge to see its condition, and you do preventive maintenance before cracks appear. So that's what electronic engineers do. They build systems that measure the world around us. Electrical engineers are on the power side, so they work with the solar panels, the wind turbines, currently the gas plants, the oil plants that feed the grid, to keep the lights on tonight. They then work on the distribution of that, which is a massive challenge. You know that we're going to have lots of wind energy in the west, but the demand is in Dublin, so therefore we've got to transfer that energy. And you may be aware that we're building a connector between France and Ireland that's going to land on the beach in Youghal and then come up somewhere near Middleton to bring power from France and to take power from Ireland when the wind is blowing and we have an excess. All part of a massively interconnected grid to try and address our energy problems. So, and again, on the electrical side, we're going to have more applications, electrical cars, apparently 1 million of them in the near future. So the electrical programs, level 7 and level 8, as well as generating energy and generating power, we also have to manage it inside a building like this, inside a factory. So how does that energy get into the speaker? You know, how do I do that? The distribution boards, the safe and efficient use of energy, that's what our electrical engineers work on. And it's a highly automated process now, so an awful lot of it is based on computer software which manages that distribution and checks the safety and looks at the distribution and optimizes the level of the distribution. Our electrical engineers work in a large number of areas. So for example, they work in automation companies where they try to optimize how processes work to save energy, designing new plant, people like Jacobs Engineering Project Management. They work in industrial plant like you know, there isn't a factory out there which doesn't have a large electrical distribution, so they'll have electrical engineers on board, like places like Pfizer, Liebherr in Killarney, who make the cargo cranes you see at the ports. And then also obviously in distribution and generation, SSE, electricity, ESB. Electronic engineering is involved with, as I said, more with circuits. So this is somebody working at a typical electronic engineering bench. So the design, the specification, design, manufacture, test, support of electrical circuits. You know, everything, as I said, from your computer to your Fitbit. The core of it at the moment is all about intelligent systems. So essentially electronic systems both collect, process, and transmit data. So, you know, the microphone is an electronic system transmitting my voice. And for me, fascinatingly, transmitting my voice to people who aren't in the room. So for me, electronic engineers, the internet was one of the great winners of COVID, you know, keeping people connected even though we were locked in our houses. And that needs embedded processors and software, things you don't think about. There's probably a processor in this projector controller, the software that works with that. The interface, I really like this one. It's got 2 buttons. Even I can figure this one out. It's got a forward and a back button. Then the communication network to transfer this data to people who are at home. And finally, one of the big up-and-coming areas is robotics and control, where, you know, robots will assist us in what we do, and that includes autonomous cars and whatever, which are effectively robotic systems. Our graduates work in some of the biggest companies in the world. Dell's, Apple, who are huge here in Ireland, Intel. They also work in telecommunications companies, Qualcomm. So your phone has probably got a Qualcomm processor, a very big presence here in Ireland. They work in research because there's a huge amount of research on how to get that data transferred to 5G, 6G networks. And finally, places where people don't expect them to work is Boston Scientific, Stryker. So a lot of those implanted devices that Matt referred to are smart. They've got an electronic chip in them monitoring what's going on. How is the knee operating, or your cochlear implant transferring data onto the inner ear if you've got a defective eardrum. The last one I want to talk about is so they're traditional programs. We have a new program called Smart Product Engineering. And this is where Daniel referred earlier to the digital world meeting the real world. So the metaverse. So this is where you take measurements from the real world, interface them with the cloud, use the analytic, the power of the cloud, and then come back with a sensible solution. So when I tell Alexa to turn on the light, my voice pattern goes to a cloud recognition system that then decides, God, he wants to turn on the light, and sends a signal back to actually turn on the light switch. So those kind of interfaces is what these people are going to make. But they've got to design it not just in terms of components or electronics, but how do humans interact with this? And in fact, the next thing they're talking about is Industry 5.0, which is technology getting away from us at the minute, and how does it better serve what we do? So these students will actually spend a lot of time working on user requirements, prototyping devices, working out, I tried that as a prototype, did it work well? You know, doing mechanical engineering, 3D printing forms to see, you know, is this a good form for a projector controller? And then integrating the smarts inside in that, which might have to go up into the cloud, do some processing and bring it back down again. And to do that, it's very multidisciplinary. So you're going to have a bit of mechanical, a bit of software, some electronics, and a lot of business and design creativity required, because actually we're at a stage now where it's quite easy. I won't say it's easy, but it's relatively straightforward to make a mobile phone. To make a mobile phone as nice as the Samsung S21 or the Apple i13, whatever they're on now, requires an awful lot of understanding of what people want. And that's the future, I think, for the future challenge for these students. And they're working on something called the Internet of Things, which is basically everything being connected in a network. And the last slide was very well kind of introed by Niall. you no longer just buy your car. So now you buy your car and it's part of an integrated system. It's a smart system. It constantly monitors what it does. It feeds that data back. That data is used to improve the next generation of car, but also to support you as the user of your car today and advise you when your gearbox is about to fail or whatever that the next stage is. And all of that is about data. And of course, taking that to the final step where the car will drive us and we can go to sleep in the back. So if I go finally, just why would you do elec eng and climate action targets? There are loads of jobs going to be actually in all the engineering. Engineers are critically required. If you want to make a contribution, this is a good way, right? Sometimes engineers is considered drab and in an office, but engineers are really going to solve a lot of the big problems. That's what they do. So we need to reduce our electricity CO2 output by 80% while increasing the demand by 30%. That's a huge challenge. That requires massive infrastructure development, requiring all of the engineering disciplines. We're going to put over 500,000 air source heat pumps to heat our houses, 1 million electric vehicles on the road by 2030. If you come to MTU, you'll be fresh graduates doing this stuff. And there's a massive career path for you in what I think are really interesting areas. Other ones, as I said, you might not think of are healthcare and in making devices that are human-centered. The last thing I'm going to say is the salaries are good. This is an Engineers Ireland salary, average salary after 3 to 5 years experience. So it's a good income as well. It's a good career to choose from that point of perspective. In terms of why go to MTU, you spend at least half your time in the labs with your lecturers. And I think that's really important, so you get to know your lecturers. In our department, a lot of the equipment you can take home with you and do the labs at home, which our students have found really useful because they're not as time constrained. They can play around a bit more. Half your assessments are based on the labs. The classes are reasonably small, and that goes across most of the college or the engineering schools. And then I think you work on individual and team projects every year. And like everyone else, there's a work placement which our students really value. Okay, thank you very much.
Thanks very much, Martin. And just to round off this session, I'm just going to present details of programmes in the National Maritime College of Ireland. It's part of the Faculty of Engineering and Science, and the NMCI is all their awards are through MTU, but the NMCI is a purpose-built facility down in Skiddy. Many of you may have seen it or had the opportunity to visit, and they offer careers for the maritime sector. So it's Ireland's only third level. It's a dedicated facility. It's a joint venture between ourselves here and the Irish Naval Service, and the Irish Naval Service, of course, is just down the road there in Hull-Bowling, and you probably have seen, you'll have seen the Navy ships coming in up through the harbour and out through Cove and so forth. And obviously there's a big tradition of seafaring in Cork Harbour, and the college builds on that. So the programmes offered are nautical science, marine engineering, and marine electrotechnology. And it's a very regulated environment. The seagoing is the national centre, but it has to all conform to international standards of professional training. And so the first programme there is the Bachelor of Engineering in Marine Engineering, and marine engineers will be concerned with all the systems on board the ship. So there could be anything from the engine room to the air conditioning to the steering system, so forth. And so they would have to monitor, maintain all of this in a very challenging environment out at sea. And with climate change, the seas are getting bigger and the waves are getting higher. So it's a challenging environment, and but graduates are well prepared for that environment. They might have seen a touch of it on Ultimate Hell Week there, where they were thrown into survival pools and all that down the NMCI. But you don't throw people in without you got to train them. But it is you know, I suppose students undertaking the career need an interest in. It's good if they have an interest in maritime affairs, but it is you know, you need to be fairly. It's a self-reliant sort of lifestyle too. You know, you got to. But you're well trained to cope with all the demands that will be placed on you. So so I can, you know, there's again, like all our courses here, there's a blend of theory and practice, and students are brought to get a very high level of professional training from lecturers who have years of experience of doing this at sea. A specialism with it is marine electrotechnology, and they're I suppose the electrical engineers who are on board ship, and it's a specialised area because there's a big move towards, as we mentioned earlier, both on land and on sea, a big move towards using electrical power generation, and there's increased use of electrical energy and more sophisticated electronic systems on board ships as well. So this is where this specialism in electric technology came on board. So with a common theme with the maritime training or education programs is there's extended work placement built into them, and that's done at sea with the various shipping companies, both nationally and internationally. And so the engineers and the electrotechnology engineers were very much concerned with the various systems on board, technical systems. The BSc in nautical science is, I suppose, that would be referred to as the deck officers. They're the discipline who would eventually move up and become ship's captains. So there's different structures within the engineering. You become a second-class engineer and so forth, and work your way up to chief engineer. In the same way, in nautical science, you work your way through the various career levels, and you can end up being captain of the ship. So obviously they're in command, and they have to consider, you know, ship in port, how you load it, how you unload it, how, you know, the cargo can be anything. Obviously in a cruise ship it's mostly passengers. You could be carrying, you know, natural gas, extremely dangerous, flammable substance, you know, or you could be just carrying cars, you could be on the ferry route and so forth. So there's 90% of the goods that come in and out of Ireland are by sea. So it's a critical, as well as being, it's a critical infrastructural requirement as well to have a vibrant maritime sector. And so there, obviously navigation and, you know, navigation and weather, you know, being able to navigate your way through different challenging weather conditions is a key part of this. And again, the college below has a lot of simulation, very sophisticated simulation environments where you can literally bring a ship into New York Harbour or Sydney Harbour or Cork Harbour for that matter in a very simulated environment, and it's actually a very effective, it's like really what you'd see. It's the equivalent of Microsoft Flight Simulator for ships. So a lot of people will go to sea and spend a lot of their career at sea. They might spend their entire career at sea, but people then, for personal or other circumstances, may look at coming ashore, and there's plenty of career opportunities there within the various industries, particularly in the maintenance facilities management area for marine engineers, because a lot of the technology discussed earlier in mechanical and electrical engineering are common to marine engineering, marine electrotechnology. And then the deck officers, the nautical science people who come on shore may end up being harbour masters, may end up being working for the Port of Cork, or other various various functions onshore. And the sea is a different environment. It has its own challenges. It also has its own law structure. So there's a whole area of maritime law and so forth. What we're going to see is a huge increase in offshore activity. As mentioned earlier, with renewable energy, offshore wind is coming very much to the fore, and certainly we can imagine that Cork will become a major centre for deployment of offshore turbine. Wind turbines have to be, they're massive structures that have to be assembled onshore and then brought offshore for and put in place, and after that they have to be maintained in situ. So there's lots of new career opportunities emerging in that sector. So that just concludes. I just presented that on behalf of colleagues here from the National Maritime College of Ireland. There will be colleagues from the NMCI here to answer any specific questions you might have in that area on the stand tonight. So with that, we'll conclude the formal presentations and we'll move to the question and answer session. So thank you very much.
Enterprise activity at the Munster Technological University is core and central in guiding and directing the development of our curriculum. We go out, we talk to industry to make sure that we have work-ready graduates so that when they come out of their programme at Munster Technological University, they are best equipped to have a successful career.
Entrepreneurship is a core part of what MTU is about. We ensure that all of our students get the opportunities to be entrepreneurs. This gives them the chance to develop their own companies and to create their own futures. It also gives them the chance to develop the entrepreneurial mindset and skill set they need, even if they go on to decide and work for somebody else rather than themselves.
So the MTU provides a strong pipeline of talent for Solaso. We hire graduates from the MTU in software and in multimedia, and actually over 3/4 of our software development team are graduates of the MTU, either in the undergraduate or the postgraduate programs there. So one of the ways that Solaso would partner with the MTU is on academic program development, where whether it's in software or in health and leisure and so on, we might suggest what the market is looking for.
The relationship between Dell Technologies and MTU has got off to a great start and will be so important in the months and years ahead. Not just in teaching and learning, but in areas of research where collaboration between industry and academia is now more important than ever. Research programs in key areas such as advanced manufacturing, artificial intelligence, cloud and cybersecurity are both impressive and relevant. We will continue to develop and explore deeper relationships with MTU going forward that will be of mutual benefit.
Now, if the students and graduates from the School of Building and Civil Engineering could come up on stage, please. So you've heard from us the different programs, the wide range of programs that we offer, the strong demand for our graduates, the good salary levels, the future that looks very, very bright. I suppose the best thing is to hear it from the horse's mouth, to hear it from our students and from maybe recent graduates, their stories that they have to tell. So I have 4 people who either are students or graduates from the School of Building and Civil Engineering, and we might spend a little bit of time talking to each of them. So I might start with you, Rebecca.
Hello, hello.
Rebecca, you are, I won't say you're the junior, but you're in 3rd year. So Rebecca came to us from Mercy Heights Convent in Skibbereen, and Rebecca is in 3rd year of interior architecture and is studying in the architecture factory, which I mentioned earlier. So Rebecca, could you tell us why you actually chose the course in the first place, and is it what you expected?
Yeah, of course. So hi, everybody. So I kind of always knew that I was interested in design and kind of creating environments. I suppose we've kind of seen from the chap's talk that you know, you experience the world around you so much, and it affects you. And I think it's amazing to be able to create that, to kind of, you know, create the spaces that people live, work, sleep, do everything in, and how it affects them. And somehow I always kind of, whenever I went into a building, I was like, wow, it looks amazing, but how do I feel in it? So I don't know, it was always something that I had, that I enjoyed and loved. And the course has been amazing. It far exceeded expectation. I was a bit of a geek, I will admit. I went to a couple of the open days over in the architecture factory. I think it's really good to go and experience the buildings that you're in and the places, and you get to meet all the lecturers and even head of departments, which is fantastic. And as the chaps mentioned, ask as many questions as you can. Not annoy people, but do annoy people. Actually, nobody will ever get annoyed at you here, essentially. Ask all the questions you can and find out all the information, because this is your life and your experience. And MTU really knows how to give you a great experience. So take a good advantage of it. And yeah, I really found that CIT, the architecture factory, has been a great place to study and learn. So even if you're not doing architecture over there, go and have a look at it, because it's really cool.
Yeah, thanks, Rebecca. And the Architecture Factory, you know, if you want to visit it sometime, you're on campus, please call down there. You'll be very, very welcome. You might just, Rebecca, it's a design-based program, and the programs in architecture are. Could you just, from your experience, what does that mean to you?
Yeah, so for us, obviously, like a lot of courses, you're looking at problems and creating solutions. So it's like that for everything. But you know, you're given a brief or a design brief, and you get to meet that through your creativity, but you're also given parameters. But the Architecture Factory and Interior Architecture is great for getting you to design things, and you have studio sessions. So, you know, you're shown loads of things, you get to learn amazing things, but you also get to practice what you preach, and you get to design in the studio as if you're working in a studio, which is great. So it's really, you get a really good experience for how work would be, essentially, as well, and it's great. It's, you know, it's really good.
So we can take it you like the course, Rebecca?
Nah, not at all. Don't go, don't go.
Okay, thanks very much, Rebecca. So Rebecca is a third-year student in interior architecture, and our next more junior student, if we call it that, would be Evan Kiley. Evan is in fourth year. Evan came to us from Coláiste Column and Ballincollig, and Evan is a fourth-year student in construction management, which isn't a design-based program. It's very much a construction program. And Evan, could you maybe just outline for us what you like about the course?
Yeah, I think the best thing about the course is it's a relatively small course. So the lecturers are very personal with us. I think because you actually start the course with a very basic level of construction, you don't have to do construction studies for Leaving Cert to do this module. So no one is given any advantages, and I just think that once you actually get a very broad knowledge of all the building environment. So in our time here, we look at the architecture, we look at engineering, and then we learn how to incorporate that into our jobs as site managers. I think it's great because we look at, we are the human aspect on site. As Daniel has said before, technology is taking over, but as site managers, we will be the human aspect on site. We take the engineers and architects' drawings and we make those become a reality. So the lecturers have been great in showing us what we can do after college, and I just think because they give us that bit of experience on what we can do after college, it gives us a really good view of what we can do.
That's great, Evan, thanks. And if you think about your journey through the program, so you know you're a final year, how can you, for people here who might be interested in your program, how did the program develop for you as a student from first year right through to fourth year? So now you're a senior student, you have a bit of experience.
Yeah, I think, as I said before, you started very basic in first year. You get to learn a very broad knowledge of construction technology and the construction industry. So in first and second year, you will do a lot of structures and engineering and just how the industry works as a whole. And then when you move into third year and fourth year, you go into specific stages of the industry, and you look at, because it is at the end of the day, it is a management module. You will learn how to become a manager and how you can be the best manager in the construction industry. I think another difference is because of COVID, we have this blended teaching, just like what we have today. We've on-site classes and we have online lectures. So I think that'd be one big difference from first year to final year, and I think it's definitely maybe a way forward, because in the industry you do a lot of meetings online and you do a lot of meetings face to face. So it's good to have that blend, and I think COVID actually worked well in some ways in teaching us how to do that.
Yeah, and to communicate with teams where everyone no longer is in the same room and on international projects. And looking to the future, Evan, you're a final year student. What do you see ahead of you in the next couple of years?
So already a lot of people in our course have received offers from major construction companies here in Ireland. That is without our degrees in our hands. Because the course is recognised in Europe, America, Australia, I have the option to maybe go abroad if I like. And I just think because it's such an open environment, you don't have to just go into construction management. You could go into building surveying, or if you want, you could actually go back and teach construction. So the opportunities there are absolutely endless. You're not put into a very narrow area or anything like that. So I think there's such a high demand right now for construction managers and site managers, and to be that human aspect on site. I just think it's a great opportunity for anyone here to come and join us and really benefit from the industry itself.
Okay, Evan, that's great. So the world is your oyster, and that program is accredited through the CIOB, which is an international organisation, and so the qualification is recognised worldwide. If we move on in the panel then to our fifth year student, so we have Aoife Hosford. Aoife joined us a number of years ago from Carrickline Community School, and Aoife at the moment is studying on year 5. It's a Master MEng in Structural Engineering programme. But I think, Aoife, you took a very interesting undergraduate pathway to get to where you are. So maybe you might just talk us through how you came to be where you are at this stage.
Yeah, so my story is quite interesting actually. I first did the level 7 civil engineering course back in 2016, it feels like years ago now. I graduated from that and then decided to do the level 8 in structural engineering. Because I had more of an interest in the design side of the course rather than the construction side, the other option to me was the construction management side, of course, but I opted for the 2-year structural. So I am currently in the second year of that structural, I'm in the second year of my integrated masters. So I was lucky enough to have the opportunity to be involved in the first year of the integrated masters here in MTU. And for me, I think just doing the masters at this time was the best decision for me, because every engineer's end goal is to become chartered, and to be a chartered engineer you have to have a master's degree completed. So I think for me, I wanted to just get it all over and done with. I couldn't see myself working full-time and having to do a part-time master's at the same time, so I think that was the best decision for me to do.
Okay, thanks very much, Aoife. So Aoife has gone through a level 7 programme, into a level 8 programme, to a level 9 programme, and now, for those of you interested in engineering, to become fully professionally accredited through Engineers Ireland, you have to do what's described as a 5-year a master's, which is typically now a 5-year program. And Aoife, I suppose the other very interesting thing in terms of your undergraduate career pathway is you've been, we talked about work placement. You might just talk us through, I understand you've been on a number of work placements since you joined us.
Yes, so I was lucky enough to be on placement 3 times actually. So I have been on placement with CISC back in the summer of 2018, which was a site job. I worked with them for 3 months and I gained like practical experience, which I still carry with me to this day. The following year then in 2019, I worked in a consulting office with a company named DJF Engineering Services. So I got to see the opposite side of engineering. So I then went on placement this year with the company named Atkins. I completed a 6-month placement, which is a requirement for the master's program, from January to June. And differently again, during COVID, of course, I had to work from home. So I've had the opportunity to work on site, I've had the opportunity to work in an office, and I've also had the opportunity to work from home. So it has definitely given me the opportunity to find myself and who I am. And work placement definitely gave me the opportunity to find out where my true interests really lie. And now going forward, I know where I can see my career going in the future, and I now know what I want to, where I see myself working in the next coming years, and I have work placement to thank for that.
And say the most recent work placement, which was 6 months, was that a paid work placement?
Yes, all 3 work placements were paid.
Okay, so it provides an opportunity to make a little bit of money to keep the show on the road, isn't that right?
Exactly, that's
yeah.
right.
and you know, employers now, they really put great store in work placement as a means to, I suppose it's like a long interview. Many of our students end up taking their first job with a work placement employer. So it's turned out to be really good. Thank you very much for that, Aoife. And last and certainly not least, our most mature panelist tonight is Terry Mackey. And Terry came to us from Colossians-Pridnave. Terry was in Colossians-Pridnave, but Terry, you're a much younger man than me. I was in Colossians-Pridnave many years before you. So I suppose, Terry, you're our recent graduate. You're currently a quantity surveyor with line sight. And could you maybe just talk to us a little bit about what you do?
Yeah, so I'd represent the client. Basically, day to day, the contractor would send in what they think they have done, as in so say there was a section of a building that they reckon they've completed and they want to get paid for. I'd then look at the claim, measure what they've measured, put rates against it, and then say to the employer representative or the client, yes, they have actually done that. So you can actually get onto the architect and release their certificate to pay the contractor. So I suppose I kind of knew about that before anyway, because I was a carpenter for 10 years. And it was kind of one of the main reasons I got into quantity surveying, because it's not alone is it just measuring and pricing. There's a lot of management in it as well. You can actually branch off into construction management, because I went in at the common level, not knowing whether to go into quantity surveying or construction management. And after 2 years, you pick. And then I said, oh, actually, I prefer quantity surveying, so I went into that instead. And it can even lead on to project management. I know people are doing masters in project management. I myself am doing a postgrad in construction law, so there's a law side to it as well. You can, there's a lot of contracts. A quantity surveyor would have to know about contracts. There's adjudication and conciliation, which is like if there's a dispute between the two, the contractor and the client, a conciliator or a mediator would have to sit down with them and basically, come to some kind of decision to solve the dispute. So, quantity surveying, it mixes in with loads of different stuff like the management and law. So, yeah.
Okay, Terry, thanks very much. So, I suppose the quantity surveyor is the construction professional who minds the money, So is a particularly important construction professional and is a very well-paid profession. We won't say Terry because people mind the money, but it certainly is true. It's a very, very well-paid part of the construction industry. Your story is very interesting, Terry. You mentioned there that you started as a craftsman, and you worked as 10 years as a carpenter, and then you came back into us to do a level 7 degree.
Yeah. So I was abroad, actually. I was in a few different countries. I was in Australia and New Zealand, and working with professionals, construction professionals, I decided to come back because, I mean, it's an unbelievable job. Like, it's, you know, it opens so many doors for you. So yeah, I came back in 2017, took the hit. I said I'd go full-time instead of part-time. And sure, I haven't looked back. I'd make the same decision again if
I mean, it's a very brave move. And looking back at your undergraduate experience now, from the point of view of a mature learner, how did you find it? Did you find that you were at an advantage, or were you at a disadvantage, or was it a bit of both?
It was a mix, really, because look, I had, I suppose, the experience of the construction industry, so I knew what they were talking about, but then being out of education so long, technology had moved on. Like, you know, like, I mean, Microsoft Excel and Microsoft Word weren't even in my vocabulary, like, you know, but within a month coming into CIT, all the skills like that came to me then, like, you know, it was,
And I suppose the final question for you, Terry, if you reflect on your time with us here, your 4 years with us here, how well did the course prepare you for working in a real job in a fast-paced, competitive environment?
It was excellent. Everything that I actually learned. I mean, because I did my final exam in May, went straight into a job in June, and actually some of the projects I was doing, I actually, you know, I'd just done them like a month before, so some of the stuff, it prepared me really well for it. It was a great course, actually.
And is it a course that you would recommend to any young or not so young people here today?
Yeah, I would recommend it. I mean, even if you did the common level like I did, you do have a choice, because the construction managers and the quantity surveyors are mixed still for the first 2 years, so you will learn both, and then you can pick in third year which way you want to go.
So that would be the level 7 ordinary degree in construction, and then you can choose to go the construction management route, or you can go the quantity survey.
In second year, yeah.
Okay, okay. Thank you very much, Terry. So you've got a flavour there of the experience of some of our students in the School of Building and Civil Engineering from third year through to fifth year, different programmes, different types of programmes, and one of our own who's now out in the workplace and enjoying it. And, you know, I would say, wouldn't put words in anyone's mouth, but I think there's a lot of enthusiasm for the programmes that they're on, and I think, of all things, providing opportunity. So that was the flavour of from the horse's mouth for the School of Building and Civil Engineering. I'll now transfer over to Matt, who will have a similar conversation with students from Mechanical, Electrical and Process Engineering. So thank you very much again. Thank you.
Equality, Diversity and Inclusion EDI ensures fair treatment and opportunities for staff and students. So by promoting equity, every individual has an opportunity to make the most of their lives and talents.
Equality, diversity and inclusion is embedded across everything we do at MTU. Our staff and students come together to identify and tackle the many barriers to inclusion so that we can achieve our full potential.
The structures here genuinely are really, really supportive for people from any background or any disability. So everybody's welcome, no matter what their background, what their creed or colour or ability, and that it's opportunities for everybody in an educational friendly setting.
For me, as a member of the LGBT community, inclusion at MTU is about more than flags and slogans, even though those things can be important. It's about understanding that a person has a background and qualities that are important and which can be taken advantage of to allow a person to achieve their full potential, not despite their background, but rather because of it.
Inclusion to me means equal opportunity and access to reach your full potential, and this was my exact experience at MTU.
Inclusion to me means that you are included in different activities, no matter your ethnicity, culture, skin color, or disability. I'm in many different societies because I love to work with different people, and I have found that the societies especially have been extremely welcoming, so MTU is a great place to make friends.
One thing around equality, diversity and inclusion that's very important to us in the UNESCO Chair is the opportunity it presents to educate a generation of students to tackle exclusion and to tackle inequality. That would really be the power of a transformative education in action.
Okay, get used to this, thank you. So I'll just work our way across the stage here. So we have students from a number of different disciplines from across the school. And the first student on my immediate left here is Owen Murphy. So Owen, I know you're in third year automobile technology and management. So can you tell us your pathway to finding your way into that program?
So I started out, interestingly enough, doing marketing in College of Commerce, and kind of didn't really know what I wanted to do. I didn't exactly do a fantastic leaving cert. Probably tried it out there because a lot of kind of numbers being thrown around tonight of high courses and stuff like that. If that, if leaving cert isn't your thing and I didn't go to plan for you or whatever, that there are other options there. So I didn't do a fantastic leaving cert, so I was kind of looking at it, didn't really know what I wanted to do, and kind of stumbled across this course, didn't even go to an open day, just was like, yeah, I'd like to sound that, and ended up doing it, and never looked back, been happy out doing it ever since. So.
And can you tell us what's the mix of subjects, or what appeals to you about the course?
What appeals is kind of diversity between all the kind of different disciplines that are covered, of that you're not totally kind of inept at anything, of that, there is a bit of ripping cars apart and attempting to put them back together again. There's a lot of business side of it, there's a lot of kind of financing, everything. So there's a bit of everything inside it. It's not that you're just stuck at knowing what's in the garage or what's going on upstairs or whatever. There's kind of a very broad range of what's kind of going on there, and I think it's kind of very important to have that for such a small kind of industry of, well, a bit large industry with a small pool of people kind of going into it.
And what industry or what type of jobs do you think the course prepares you for? And
kind of anything you want to be except for a mechanic, which is only an extra 2 years add-on actually to the 3-year course. If you want to go to be a fully qualified mechanic, you actually skip the first 2 years of the course and you're fully qualified in 2 years after it then. So if that is kind of you went into it realizing actually I kind of want to be a mechanic and easy enough, whatever, it's only an extra 2 years added on to do it, so it's not the end of the world either.
Yeah. And your own, did you get any opportunity to work in this industry during the program?
Yeah, I've had a few. Alright, I was working in CAB Motor Group, the Ford dealer in Monaghan Road, for 3 or 4 months as a general operative, which is, I'll be honest, kind of sweeping the floor and washing cars, and generally as a whole being screamed at to do stuff they don't really know how to do. But genuinely fantastic insight into the industry and a very kind of good guiding hand into how things work. I was kind of doing something different every day, and I found it very interesting. And then just this last summer, then I was doing piloting a marketing thing for a Kia's car store, kind of doing lead generation for them. Now it didn't end up so fantastic in the end that it ended up cutting the contract, but once again another very fantastic insight, and working with probably one of the best people in the industry, Johnny O'Connor, who, if any of you probably own a Skoda, he's probably sold it to you. So it's a fantastic opportunity, Jenny, to work with him, right?
And having been through all that now in your experiences, what pathway are you mapping out for yourself now?
So I'm hoping to move over to the UK in probably about a year and a half, 2 years, and go work for McLaren, hopefully, kind of doing their marketing and events and stuff like that, kind of what I'm doing here actually, except for the cars and the kind of the brand and stuff like that. So kind of more brand management, just due to the fact I have the slight bit of history into marketing and stuff like that. That the qualification is there. And
would you say would you have to be really into cars now and engines and all that to come on the course?
I wouldn't say like a knowledge of it is very important, because actually they go quite in depth without being boring, if that makes sense. But I'd say even more important than the points or anything or knowing anything is just having draw genuine interest in cars. That's one of the few courses it's, you know, a lot of courses is like you all kind of like the idea of it or whatever, whereas with my course, it's a lot of, you're actually just interested in cars, and that's what we all have in common, is that we're all into cars, we're all kind of in the same pool as that, so it's kind of the interest all kind of feeds into it, and everyone kind of enjoys it a little bit more. So I would say an interest in cars is very, very important to it, but more than the knowledge, really.
Yeah, okay. And how many typically in your class, or what type of activities would you be doing?
So generally, there'd be between, I'd say, kind of about 8 to 12 in a normal class. It's a fairly small course. I think we started out with 14, and you know, we didn't even have 2 dropouts. Just moved to different courses, but generally it'd be kind of, you know, like at the moment now we're doing transport regulations and stuff like that, which there is quite a lot to, but is very interesting and very important thing to learn about once you're into the industry. In first year, then for example, we were doing a lot more of the kind of the engineering side and mechanical side of it, actually in the garage ripping stuff apart. Second year then is a little bit kind of more truck based of the transport industry. But yeah.
Okay, thanks very much, Owen. So thanks for those insights into the automotive and transport side of the house. So we move along next to Olivia, and Olivia's a second-year electrical engineering student. So I know you're. So can you tell us, Olivia, what got you interested? I know you came through Ashton and that, was it? And what got you interested in electrical engineering?
So growing up, I actually always loved circuits. I used to look at things and ask how they worked. I asked a million questions growing up as to how things worked. And I actually got into lifetime labs in primary school, and we ended up building circuits. And I found kind of an interest through that. And I kept that going the whole way through, and I did VEX robotics in secondary school. And then I actually moved school to do engineering, but I had left. And there was no spaces in the engineering classes in my school, so I ended up doing business-based subjects. And I did business for a year in CIT, now MTU, for a year, and realised, look, no, wasn't for me. So I decided to go into electrical engineering, and I'm in second year now, and I absolutely love it. I love the mathematical side of it. I can be quite a black or white person when I'm thinking, so using numbers to kind of express how things work for me seems to be the nicest way forward out of engineering subjects for me. So yeah, and I like how it's a very small group. There's only 22 in my year. I'm actually the only girl, which is great. So I get the 2 sides of it. And even in our labs, there's only 12 we're split. So you really get that kind of one-on-one with a lecturer. You can email them afterwards if you don't get something, and they will be back to you straight away, or they'll even come in and show you through the lab again, one-on-one, which I find amazing. That you really get that personal feel to understand something, because electrical, you can't see a lot of what's going on. So that really in-depth understanding of how these things work helps a lot. So that one-on-one really makes life a lot easier.
And how about the hands-on side of things? Do you get much exposure to actual electrical circuits and that since you come on the program? Yeah, so in first year, obviously since we were at home, the department did amazingly. So we got the microchip boards, and we could build circuits at home, which I found amazing because you weren't limited to that hour in a lab or that 2 hours in a lab. So I could be sitting at home some evening. I could even be watching TV or something,
and maybe I wasn't getting the circuit or wasn't getting the reading I needed. So I could just sit at home, play around with it. If I didn't get it, email a lecturer, send them a picture, and they get back to me with why it wasn't working, and they'd explain. I could go back, rebuild the circuit, and kind of have that idea. And now that we're on campus, we kind of deal with stuff that are a bit bigger, and you can plug in wires, you can play with wires, you can turn all the knobs and see the different numbers moving, and change voltages and stuff. For me, it's a nice visual of electrical, because electrical, there's a lot of thinking behind it. You don't see the current, so being able to plug and play things is amazing when you're on campus.
And why did you go for electrical rather than the electronic side of the
I like the bigger scale stuff. I'm not as finicky for electronic. I like the bigger scale stuff. For me, what I'd be interested is in distribution, those smart grids that they were on about earlier. For me, it's efficiency, and I love trying to make something as efficient as possible. Just even the renewable side of it. If I can contribute maybe in a few years to making that grid an extra bit smarter, or being able to turn on lights for much cheaper, or that side of it, I'd find a lot more interesting for me anyway. But definitely the electronic side, if you're interested in finicky work and just like small things and that's smart technologies, or like your phone, I think it's an amazing course.
Yeah, okay, so I hope Olivia sparked your interest there now.
Hopefully anyway.
So thanks, Olivia. And I'll move next to Katie. So Katie, you're in fourth year Biomedical Engineering, is that right?
That's right, yeah.
Yeah. So can you tell us what that entails?
Yeah, so I suppose biomedical engineering, it's very like mechanical engineering, but it's applied to the kind of the biology side of things really. So you're looking at a lot of medical devices and anything to do with medicine really. So you do a lot of biology subjects, but you also do a lot of the mechanical side of things as well. So we do a lot of our lectures with the mechanicals. And you kind of do a lot of practical stuff. You know, we do a lot of labs where you're applying your theory into practice, and then we do a lot of projects as well. So last year especially, we would have done one project. So during the IPD module, where you're in a group with the mechanicals and business students as well. So you take a product, you make it yourself from concept design, and you bring it to market basically. And with that module as well, you kind of get an opportunity to enter into competitions and win a bit of money for yourself as well.
And what product did your group develop as part of that?
So part of that, the project manager of the group, he was a volunteer at the RNLI in Kinsale, so he made a man overboard detection device. So it's very interesting.
And can you tell us how far did you go with that idea?
Yeah, so we got best pitch in the MTU Student Enterprise Awards. We were in the final of the Ireland Funds Business Plan competition, and we also placed in the final 10 of the Enterprise Ireland Student Entrepreneur Awards.
So very good. And and what other ideas? There was other groups in the class, obviously, as well. Was other ideas as well?
Yeah, definitely. So a lot of really innovative stuff. So one project that went really far, they won the National James Dyson Awards, was the girl in the group, she would have done ice skating. So her project would have looked at the jumps of the ice skating and kind of measuring how far they can jump and all that kind of stuff.
Very good. And what supports do you get in developing the projects? What supports do you get along the way?
So every group is assigned a supervisor, so one of your lecturers will be helping. So we have Hugh and Paul over there, they'd be the main two. So they'd be meeting you every week, kind of moving you along, progressing, and you have assessments. Then you present your every stage of the project to the lecturers about every 2 weeks.
And you know, in terms of designing and making things, what exposure do you get to different technologies or tools or during the program?
Yeah, so you do a lot of practical stuff. So part of that project, I would learn a little bit about Arduino, which is something I never really thought I could do. Coding was not my thing at all, but it's something that I definitely have an interest in now since that. Other things then as well, you're looking at biology, so you look a lot at the body. So you've one part of third years, you have a cadaver lab, so you get to go to see and actually see the parts of the body, which is something pretty interesting.
And how was that experience? There was anyone faint or anything?
No, not that time, no. Not something that I particularly love, but definitely an experience.
Yeah. So it's a unique opportunity on the programme. It's a cooperation with UCC, their Faculty of Medicine Health, that you get the opportunity to visit their anatomy and physiology department. So you'll be finishing up the programme this year, Katie. So what are your plans from here on out?
Yeah, so hopefully I'll be getting on to graduate programs. So at the moment, kind of going through a few interviews with different companies. So I'd love to get a graduate program where I'm rotating through different departments, seeing the different type of jobs you can get. So you could be an R&D, or you could be a manufacturing engineer, or quality engineering. But what's great about biomedical engineering as well in Ireland is that there's a lot of companies that are American and international companies, so you get a good chance to get abroad on those programs as well. But not only would you get opportunities to be in big companies, there's a lot of startups around the place, especially in Cork and Galway, your two main hotspots for the biomedical industry. And if you're interested in entrepreneurship, it's a great course as well, because the college work closely with the Rubicon, and there's the student Inc as well for anyone that wants to start their own company.
Yeah, okay. So best luck going forward, Katie, and I'm sure there's plenty of opportunities out waiting there for you. So we move to the man on my extreme left there, Leon Domini. So Leon, you're finding your sustainable energy engineering. So can you tell us how you came to choose that program?
Yeah, so I was originally actually went to UCC for 1 year. I was doing a chemistry course in UCC, and I decided to come to MTU to do a course that applied the theory more than what I was currently doing in UCC, and I definitely got that in MTU. I came into the course, preconceptions of just working on solar panels and wind turbines, but it was such a broad, it covers such a broad area of energy technologies and how they're implemented into so many different industries. So it definitely delivered on that aspect. One of the highlights of the whole course was the two work placements that I did. One recently with a company called EM3, where I was working on a varied amount of projects, from solar PV projects to energy management projects, where I was dealing directly with site managers to highlight problems with their processes, see areas where they could improve. And I got to actually travel to Germany with the company and partake in a site audit, which was incredibly interesting to see. That I wouldn't have been able to get that opportunity without going to MTU and having all those contacts. So it's very interesting, and it allows you to go into so many different areas after. Like it's coming into the course, I knew I was interested in energy and very interested in climate change and wanted to implement those solutions, but I had no idea really what that actually meant. What was I going to be doing day to day? And I'm still unsure, but there's so many opportunities to me now next year. And that's probably one of the highlights from the course as well, that you're not fixed. When you do the course, you're not fixed to any one thing. It's so varied. You can start your own company, you can get into huge multinational companies that are already existing. So it's a very interesting course, very rewarding. Yeah.
So there's obviously huge challenges out there, with the climate action and so forth. So, could you see from your time in the company, are we making, or were they making an impact in terms of what they were doing?
Yeah, huge impacts. There's a load of very interesting projects ongoing in Ireland as well. We've huge amounts of natural resources that we can use, and it shows as well how high the demand is for energy engineers. I went into EM3 as a on work placement. I wasn't even a qualified engineer, but I was involved in so many projects and dealing with customers straight away, and seeing how the deliverables, I was doing a weekly energy management report that I was sending out to the customer, And then we were having bi-weekly calls with the managers to try and see where we could improve. And like, I was never expecting to do that, and it just shows how important those management systems are and how, high demand there is for this area of engineering as well,
Yeah, well, I suppose, as they say, if you can't control, you got to measure something first before you can make improvements, so you got to know where you come from. You also had the opportunity to do an Erasmus placement, so could you tell us a bit about that?
Yeah, so I went to Prague in the Czech Republic now. I did one full semester, and then COVID came along halfway through the second semester, so I had to cut it a bit short, but it was incredibly interesting. I'd highly recommend it, regardless of what course you do, is to just go on Erasmus. You meet so many people. I've made friends for life in that short time, but it shows you what else is available out there as well. Like, you make so many contacts through college and companies over there as well. Like, I would have never have thought to go to the Czech Republic for work when I finished, but after doing the couple of months there, like, it's definitely opened up all those opportunities for me as well now. Yeah.
And how well prepared were you, or did you find it tough going over there? How well prepared were you for it?
Yeah, like, the course, the subject that I was doing was very similar, and what I'd learned, the foundations that I'd learned in first and second year in MTU really helped me when I was over there. One of the bigger things was actually the language. Now, it was all through English, but there's different levels of English from some of the lecturers, so that was a big challenge when over there. But no, it went very well. Yeah.
Okay, and you're finishing this year. You've defined your project now, I presume. So, can you tell us a bit about that?
Yeah. So one of the issues in Ireland due to COVID and other problems is that we're dumping a natural resource of sheep's wool, and that might sound a bit unusual, but it's an incredible material that we can use to insulate buildings. NASA use it for their astronauts in the material they use to go to space. It's an incredibly interesting material. So I'm looking into utilizing that. I'm looking into testing the thermal properties of it. I'm designing a test rig to test those thermal properties, to see how it compares to other wool in other parts of the world. In Ireland, we have such a climate that it actually produces wool, which makes it specifically good for insulating buildings. You might have heard of merino wool, which actually is very bad for that application. So that's what I'm focusing on now for the project.
Okay, thanks, Leon. And I suppose at this stage, I'll just thank all the speakers for their contributions here tonight and the insights to give into the varied opportunities to study here and to progress from here out into the world of work. So if you can show your appreciation to our students, please. So thanks very much for your attention. We'll draw the formal proceedings to a close. I'm aware that we will have our students, I presume they'll stay on for another bit anyway, so if you want to ask them any individual questions, our staff are also here at the stands around the hall, so you're more, as Martin said earlier, I encourage you to go and ask plenty of questions for them. And so we're open all night here now. So anyway, thanks to everyone for coming. I hope you enjoyed the evening. And to those online or to those here tonight, you can send further questions to CEO@mtu.ie. So thank you very much and enjoy the evening.